Well, we had a bit of a setback. I put the electronics back in the guitar, buttoned everything up, hooked it up to a GM70 so I could exactly measure all of the outputs, and all of the controls on the guitar worked great. Touchpads, LFOs, the works. When I went to play all the strings, there was no output from the D string. So E, A worked fine, G, B, and E, but the D string was dead, which was very disappointing to get this far down the road. I did check the hex fuzz output, and there's no hex fuzz output from the D string either, which means that the failure is happening fairly early in the signal path. Now what I've got here is a multimeter hooked up, and I'm measuring the resistance across the elements in the hex pickup. So the black clip there is connected to the common point for all the elements, and then the red clip is checking each element on the pickup. And right now it's on the fourth element, which is the D string. And I can see that I am getting around 800 and some ohms, which is great. So all the elements on the pickup so far check out. So it seems like the pickup is still good, which is very, very good news, because repairing a pickup can be quite difficult. So now I'm back to looking at the schematic to see what else the problem might be. And I'm thinking that there may be, if you look at the signal path where it comes in, there could be a problem with that initial capacitor there. I'm looking at the G505 schematics, because the circuit board layout on the G505 follows the revision C board. So this tells me what chips are being used for what parts of the circuit. But if I want to look at the actual values, then I need to go back and look at the, well, I don't have it here in front of me. I have it underneath here. I need to go back to the G303 schematic. And on the G303 schematic, that first capacitor that we have that's rolling off some of the high end, it's got a value of 0.01 microfarads. So if that capacitor has failed, and sometimes these capacitors will fail, then the signal is being grounded out before it can really do anything at all. So what I'm going to do is test, just do a little continuity test on the, measure the impedance on the electronics board, just to see how all those, if I measure from where the hex fuzz pickup plugs in and just measure that resistance to ground. I'm just kind of curious to see what those numbers are, if anything jumps out immediately. And then before I put the electronics back in the guitar, I'm going to make a little test rig, because I don't want to keep inserting and removing the electronics card. I feel like that's just going to increase the chance that I do some kind of permanent damage that's going to be difficult to recover from. So this GM70 that I took for parts, that I removed the 24-pin connector from, I'm going to remove the 12-pin socket on that, and then I have the leftover bit of a 12-pin from here. This was, as you recall, the 24-pin ribbon that wasn't working correctly. So I'm going to make like a little extension tool so that I can plug into the ribbon. Is going to plug into this little extension tool, and then I don't actually have to have the circuit board sitting in the guitar to be able to test the guitar and see what's going on. So I hope it's as simple as something as that capacitor. Otherwise, it's going to be time to break out the oscilloscope and to start looking at the signal along the signal path. Okay, we've got the oscilloscope on, and I've got a test probe hooked up here. So I'm going to start with our troublesome D string. I've got my probe on there, and I'm going to hit the D string on the guitar, and definitely I have level there. So let me check the A. Okay, next to it is going to be the G string. So let's check the G string. I just need to move the probe one over. And there's the G string. I'm going to check the A string, which is going to be these 1, 2 over here. This should be the A string. Oh, sorry, on the wrong string. Right, this would be the E string. We're going to slow that down a little bit, maybe, get a little better. Yep. So there's the E string, and check the A string, right? We already checked, I believe this is the B string. Yep. And we'll turn the time divisions up so we get a better look at that. And then finally the high E string. Let's see. So I'm getting output from all the strings on the pickup, and the level's pretty comparable between all the 6 strings. So at least at this point, using the test rig, I'm pretty consistently getting what I expect to see from the different elements on the pickup. So it's kind of turning the attention to is there an issue with the operational amplifiers in the board, because that's active electronics. And I think that would be the next place where we could maybe start to wonder if something is not working correctly. But I'll keep the oscilloscope around, because we can use this to also trace the signal path once we've got the electronics hooked back up. Well, this is a puzzler. So I tested the output from the pickup, and I know that it's good. And I've got the extension now, I've got the card hooked up, and I thought, well, before we go any further, let's just fire up the GM7 and see what's happening. So here's the E string, good signal there. A string, good signal there. D string, working just fine. D string, working just fine. G string, B, and E. It didn't work when it was in the guitar, but it's working now. So just random speculation. One, I did rotate the trim pots completely when I was getting ready to do some of the testing. So it could be that maybe there was just debris in the trim pot for the D string. I kind of doubt that. The other possibility is that just as we've been experiencing with these ribbons, that there's some angle that's compressing the ribbon connector for the pickup once everything's inside of the guitar, or maybe there's a control pot that is touching on some element of the D string signal path that's causing a problem. Because right now I haven't really done anything and everything's working just fine. So I'm not sure where the problem is. I'm not able to reproduce it with the card outside of the guitar. So I guess at this point then I moved towards putting the card back inside the guitar. I was ready to start to unsolder some chips and various things, and I'm glad I didn't do that, because I would think I did something to solve the problem when in reality I didn't do anything at all. Okay, well, let's see what happens. So everything in the guitar is 100% working as expected. So I am not 100% sure what the problem was, but there was a shielded wire that carried the signal from the 2 humbucker pickups, and that had some exposed ground wire. And I think that that may have been touching against the conductor for the D string, because I put some electrical tape around that wire to shield it, or not to shield it, but to isolate it. And when I put the card back in the guitar, everything worked great. So this is the card inside of the guitar. I did use one of the standoffs to help to anchor the guitar. I needed to drill a new hole. But other than that, the card seems very stable. You can see there's a slight bend now. That was not there before. This was a brand new, 24-pin connector that I pulled from the LPK-1 kit, and it kind of looks like the one that had been in there for a while. And so otherwise, everything is working great. Let's rotate this guy around. And yeah, so there you have it, a vintage 1980s Les Paul with the Roland LPK-1 kit installed, and everything working great. And if you happen to run across one of these, they are really, really, really nice guitars. Of all the guitars I've ever played, this thing probably has the fastest neck on it. It's just without me making any adjustments, the action is very low. And of course, it's really great to be able to use this really nice Gibson Les Paul, not only with the vintage Roland GR gear, but I'm using a BX13, and I'm able to use it with the Boss X SY1000 as well. Okay, I hope this was helpful, and please subscribe. Thank you. Bye-bye.